Hi, I'm Richard Ye, a developer advocate engineer here at Zoom. Today, I'd like to tell you about how you can build your very own first iOS application using Zoom's Video SDK. With this set of powerful software libraries, utilizing underlying technologies, you will be able to build your very own first video conferencing application that can support up to 1,000 users per concurrent session. With the Video SDK, you can also have access to many other powerful features from Zoom, from chat to live streaming to screen sharing, which we'll explore today. So for this sample application, we will be using Swift to build an iOS application, but the Zoom Video SDK is also available in Objective-C. So let's get started. First, let's download the Zoom Video SDK to our machine. Starting at the Zoom App Marketplace, go to Develop, then Build Video SDK. Here, you can see information about your Video SDK app. Under Download, go to iOS and simply hit Download. Now, in Downloads, let's take a look to see what's underneath the actual SDK directory. All the important frameworks are under sample libs. You can take a look at a sample Zoom video app here, but under lib is where all the frameworks live. For this app, and as with any other video SDK app, you'll want the Zoom Video SDK XC framework added to your project. If we were to have a full-fledged broadcasting app, you would add the screen share framework as well. However, because we're going to be sharing a single UI view in our app, we would simply need the CPT Share XC framework. There's also two other frameworks as well, which more information are provided in the documentation. Let's take a look at the app we're going to build. The My Sample app for Zoom Video SDK consists of two views, a start view from which you enter the Zoom video session, and then the session view itself with a UI tab bar controller. This tab bar controller controls the 4 different capabilities within the app: toggling the video on and off, muting and unmuting the audio, sharing the current screen, and ending the session itself. If you'd like to follow along with the documentation, as well as this video, you can take a look at the template repository, which contains the bare bones skeleton of this project, with helpful comments that tell you exactly where to fill in the code as you need to get a functioning app. In order to use the Zoom Video SDK, you first have to authorize it for initialization. You do so using a JSON Web Token, or a JOT. Within the JOT, there's several sections. First, there's a header with a signing algorithm and the type of token, a JOT. Under the payload, there's several required fields. First of all, there's the app key, which you'll see under the App Marketplace, under the SDK credentials section, under SDK key. That's what you'll set to the app key field. You'll also need the SDK secret as well, with which to encode the payload with the signing algorithm. Other required fields, including TPC, which corresponds to the session name. You'll have to remember that later on when you generate the video session. You also need the row type. Here, we'll just set it to 1 because the current user will be a host, as well as the time that the token was initialized and the expiration time, which we'll set to 48 hours after the initialization time. Generally speaking, you do not want to generate the JOT client side. You don't want to be saving the Video SDK credentials on the app itself. However, for reference, here is some sample code in Swift illustrating how you would create your JOT. Ideally, you will want to create this server side, and your client would fetch it before initializing the SDK. For reference, let's take a look at the Zoom Video SDK jot that we've generated ourselves. For example, here is a Zoom Video SDK jot. Here you can see the headers marked, as well as the app key, the version, the 2 timestamps, the TPC, which corresponds to the session name that we've hard-coded in the sample app, as well as the row type. Here, this would be where the SDK secret would be in order to decode the jot. Let's get started with integrating the Video SDK into our Xcode project. First, navigate to your Xcode project file. Confirm the minimum deployment target is set to at least iOS 11.0. Next, you'll be taking your libframeworks folder and adding the relevant XC framework files to your project. For this sample app, we'll want to add the Zoom Video SDK XC framework, as well as the CPC Share XC framework. Confirm that the actual frameworks are embedded and signed. Next, we'll want to go to Build Settings and make sure that bitcode is not enabled. Finally, we'll want to go into info.plist and add the relevant privacy permissions information. In this example info.plist, the privacy permissions have already been added. You'll want to use the microphone usage description, the Bluetooth peripheral usage description, and finally, the camera usage description. These 3 are required for Video SDK to work. However, you can also add the photo library permission optionally. Next, let's get started by initializing the SDK itself. We'll initiate the Video SDK in the Start View controller, which is the entry point into the app. First, on top, we'll of course import the module itself. Next, in the Setup SDK function, what we're going to do is actually initialize the SDK. To do so, we first create the initialization params object. We'll set the web domain, which is a required value, to zoom.us. Then we'll attempt to initialize it using a shared instance of the Zoom Video SDK object. If the error's success status is received, it means the SDK initialization has been successful. If not, we receive an actual error. Before we move on to the session view controller, let's just take a quick look at the rest of the Start View controller. Upon the loading of this view controller, we create the Enter Session button. This session button simply creates a new instance of the session view controller and presents it when it is tapped. Now that we have the Zoom Video SDK initialized, let's go ahead and see it in action. We'll set a breakpoint here and then build and run. As can be seen, it's initialized successfully. Now we're ready to move into the session view controller. Now that we have successfully initialized the SDK, we will next join a session. A Zoom session is similar to a video meeting, and it includes feature capabilities such as chat or screen sharing. Let's enter the session view controller. Remember to import the module again at the top. Next, we'll fill in the relevant session information here. In this sample app, I've already generated a sample jot previously, so I'll set it as the value of token. But please remember that in a production app, you should not hard code such credentials. The best practice is to fetch the jot from a server. I'll also use the same name for the session name as the value of the TPC field in the jot. The session name is a unique identifier for the session. It's specific to your developer account, so rest assured a different developer's app can also share the same session name. Also, I'll set the username. Next, we'll fill in the relevant code under the joinSession function. Here, we create a session context object and fill in the properties from above. Then, we call joinSession. With this function, if no session currently exists with that name, a new one is created. If there is a session active with that name, then the app calling joinSession would join the existing session. Now, let's see this in action. There you have it. We've joined our first Zoom session. You'll want to conform to the Zoom Video SDK Delegate protocol in order to listen to callback notifications from session operations status updates. Now that we've wired up our app to listen to Zoom Video SDK Delegate callbacks, let's use them to stream video. The on-session join callback is triggered when the current user, i.e. the user using the app, joins a Zoom session. In this callback, we'll render the video in the app as soon as the user joins. To render the video stream, you first need to access your current user's user object. With this user object, you can access the user's corresponding video canvas. The video canvas is the display area where the video streams to the device. You check the video status of the canvas to make sure you're not already streaming. Finally, you pass the video canvas the specific UI view you want to subscribe to with a stream. Please make sure you do this on the main thread. Now, let's see this in action. As you can see, the video stream is now active. Now that we have subscribed to the video stream, let's take full control of it. We'll do so in this tab bar controller callback. Each of the tab bar items on this tab bar controller accesses a different control of our app. For the first one, we're going to toggle the video. First, we get the user's video canvas. Next, control video helper. It's an interface used for managing video and cameras during a video session. We check to see if the video streaming from the video canvas is on. And then we call stop video to stop an existing video stream. If it works, we update the UI of the tab bar item. If the video is off, then we start the video and update the UI accordingly. Let's control muting and unmuting audio in a similar fashion. We'll again place the code in the UI tab bar controller delegate callback. When we select the second option, toggle audio, we first fetch the user object and ensure the audio status exists, which means the user is connected to audio. If they're not yet connected, we use the audio helper object to connect the audio via the start audio function. If we're certain the user is connected to audio, we can toggle it. If the current status is muted, we simply have the audio helper call unmute audio, then update the tab bar item UI accordingly. If the audio is currently unmuted, we simply do the opposite by calling mute audio. We then update the UI. Now, let's see this in action. Let's talk about screen sharing next. Screen sharing in iOS with the Video SDK can be accomplished in two ways. One is with full device broadcast, and the other is to share a single UI view. In our sample app, we will demonstrate the latter. This requires the CPT share XC framework file, which we've already added to the project. Here in the tab bar controller callback, we will add the code to enable sharing when the user taps on the control. We first fetch the share helper, which is a control interface for screen sharing features. The share helper then calls start share, passing in the specific view that we are going to share. In this case, we're just going to do a test share of the loading label that was present right before we joined the session. Because screen sharing mirrors the exact state of a specific UI view, we want to make sure that it isn't hidden or otherwise obscured when it's being shared. So backing on session join, we'll want to remove this line. Based on the return value, we see whether this is successful or not. When the status of screen sharing changes, whether to start, pause, resume, or stop, the on-user share status changed callback is called. In this case, we're expecting it to be called after start share succeeded. Here, we'll implement the actual code to display the screen sharing once its status is set to start. As with streaming video, we must have a video canvas subscribed to the screen sharing. We also have to make sure that the subscribing happens on the main thread. To subscribe, we specified the display view with which we render the stream. Here, we'll simply use the same canvas view that we use for video streaming. If the screen sharing has been stopped, the video canvas should also unsubscribe from the stream. We'll get back to this later when we end the session. Now, let's see it in action. So now we have the basic features of a Zoom session. But how do we end the session? Let's implement the final option of our tab bar control. We first make sure that we stop any screen sharing in progress. Next, we simply call leave session. Leave session will trigger the on-session leave callback function. This is called whenever the current user, that is, the user using the app, leaves a Zoom session. In this callback, we're going to do some cleanup. We need to unsubscribe to any video or screen sharing streams with our video canvas. In this example, we only do this with the current user, but if we had other canvases with other user streams, we would do so in the on-user leave callback, which is called whenever a remote user leaves the Zoom session. So as you can see, we want to make sure we unsubscribe to both the video canvas and the share canvas. Let's see this in action. And there you have it. You've successfully created your very first Zoom Video SDK app. If you'd like to learn more, please check out Zoom's developer website for documentation, more tutorials, and the official developer forums where you can have your questions answered. Thanks for joining me today, and we wish you the very best in your coding adventures with Zoom's Video SDK.